So in the last example, we reached a convenience level, or we found out that the broadcast ID should be 10.0.3.255. This is what happened to us in the last video. If I would clean my board a little bit, I would tell you that the broadcast ID, which is the odd number, is 10.0.3.255. What is the next IP after that? 10.0.4.0. First, this is an even number, correct. Second, it's the beginning of a new network, correct. Let's use it to be at our most investing level. Let's use 10.0.4.0 as a second example in the CIDR domain. So today, what do we have? 10.0.4.0. All right. Which is example number 2. Okay. This time, the request in the slides that I wrote for you said, design it for 300 consumer. Step number 1, the diagram, done. Step number 2, come and write 300 plus network ID plus broadcast ID equals 302. What follows that? Compare it to the diagram. Okay, which of you has a total addresses that is enough or a little bit more? You. 512 is a little bit 190 addresses excessive, but it does not provide any shortage, so it is enough. Next, draw the line between what was enough and what was not enough. Next, fill those on the right side with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. If you did so, then what you should do right now, 32-bit minus 9 zeros equals or results in 23, which is the subnet mask. So now you know that 10.0.4.0/23 is a network that is enough for 300 plus employees. Investing the most, wasting the least. Homework for yourself, go and do the VLSM. Pause the video, do the VLSM. After you return, you should find the numbers look like this. The numbers should look like this. 10.0.4.0/23 was the network ID, and the broadcast ID would be 10.0. The increment value is the number that is left to the line, which is 512, couple of networks, so that will be 5255/23 is the broadcast ID. Use whatever I taught you in this course for the VLSM and see if the numbers meet or not. This is example number 2, screenshot, and I am proceeding with example number 3 and example number 4 in this video, because things will start to speed up, not to slow down. We'll start to speed up, not to slow down. Take the example off. We are proceeding. Take this off. Take this off. Let me ask you a question. The broadcast ID is even or odd? Odd. We have reached the last IP address. If you have done or if you did the VLSM correct, you will reach to 10.0.5.255. This means that the IP address after that, 10.0.6.0, is the next network ID for a different new network. Am I right? Hopefully, yes. So this is the new network that we will start with right now. Saying 150 consumers. All right, 150 consumers. Example number 3. Okay. First step, diagram, done. Second step, comparison. Oh no, I'm sorry. Second step, 150 plus network ID plus broadcast ID equals a total IP addresses of 152. Next step is comparing. 128 is not enough. 256 is enough. Let me have a line here. Let me have a line here. What's left right to it will be what? Zeros. a 0, 2, 3, 4, 5, 6, 7, and 8. Good. If it was an 8, then what I should do, 32-bit minus 8 equals a 24, which is the subnet mask. Done deal. Just done deal. If it was a 24 and a 24 only, then I do believe it will be like that. Go and do the VLSM and come back to me. Go and do the VLSM. Take your homework with you. You should come back to me with 10.0.6.0/24 as a network ID. This is super obvious. 10.0.6.255/24 as a broadcast ID. It's in that way. Believe it or not. This is a screenshot. For the third example, we have 1/4 and last example for CIDR, because yes, it is that simple. Screenshot number 12. And this time we are taking 50. Number of consumers of 50 for the last example, which I hope for you was clear, useful, makes sense. Using the techniques of the VLSM, you will continue. You will master IPv4 design, subnetting, supernetting, which is CIDR, means sometimes they call it supernetting. Subnetting is VLSM, supernetting is CIDR. So 10.0.6.255 is a network ID leading to 10.0.7.0 as the next network ID that we are about to use in our last example. And our fourth and last example for the CIDR in this video. Only the last one. So this is, all right, 50 consumers, okay? The rule says 50 plus network ID plus broadcast ID is 52. The other rule says start comparing, Sajjad. I will start comparing. 32 is not enough. 64 is more than enough. A little bit of excessiveness is there, not a problem. What's on the right should be 0, 2, 3, 4, 5, 6 zeros, leading to 32-bit minus 6 zeros equals 26 bits, which is the subnet mask. Done. Don't forget that the enough number is the increment value. You can use this hint when you are doing your VLSM homework as well. Also done with that. So if I have an increment value of 64 and I'm starting from 10.0.7.0/26, then I should be ending with 10.0.7.63 as a broadcast ID for that network. How? Use VLSM. Didn't we have an example already of /26 and /24? You are lucky. So it will not be really that much for you. This is the fourth and the last example in the CIDR. It should be the end of the course, but I believe I will just be adding a next video, just talking a little bit about some services related to IPv4, just excessive info, not related to a specific exam, but just to end this course. Thank you, and I will see you next.